Okay, welcome everyone to the video demonstration of the second spreadsheet exercise for the soils topic. In this spreadsheet, we're going to generate some water retention curves ultimately, but to get there, we have to go through these other two steps over here. So to facilitate ease of publishing videos to YouTube, I'm actually going to be doing this in 3 separate steps as opposed to one whole long video doing the whole thing. Before we actually even get started, the first thing you probably want to check is that you have the solver function enabled in Excel. If you don't, or you can't get it up and running, then there's no way to actually do this experiment because you'll need it to do step 2. So where you can check whether you've got the solver function running is under the data tab, and you should see solver over there. If you don't see it there, what you need to do is go to File, Options, Add-ins, and under Inactive Application Add-ins, you should see Solver Add-in down here somewhere. Because I've got it activated already, it's under Active Application Add-ins. But if you see it under here, Inactive Application Add-ins, just click it, right, like that. But except it'll be down there, and then click Go over here, and then you'll see Solver Add-in, but you won't have a tick there, right? Just give that a tick and click OK, and that'll make sure that the solver appears under Analysis, under the Data tab. Okay, once it's there, you should be fine to go ahead with the rest of the worksheet. If you can't get the solver bit up and running, you really won't be able to complete this worksheet at all, so there's no point even doing step 1. Of course, those instructions are specific for this version of Excel. If you have a different version, you should still be able to access the solver function. How you go about doing it might be slightly different, and you may have to actually look that up. Okay, well, to kick off, we'll have a look at exactly what we're doing with this worksheet in step 1. So in step 1, what we're actually going to be doing is figuring out predicted water contents at given matrix potentials for 5 different soil types using a pedo transfer function. Now, what a pedo transfer function is and how it works is something you're probably going to have to look up yourself, because I could spend a very long time talking to you about that, and that's not the point of this tutorial. So this is the equation over here, which actually is the pedo transfer function, and it's going to give us our water contents. And our soil types, we've got 5 different soil types, and they are classified according to their clay, silt, organic carbon percentage, as well as their bulk density differences. You'll notice that sand is missing from this classification, and it's because you will actually have to derive it over here, right? So to begin with, we want to ensure that we've got soil number 1 inserted here. So if it isn't there already, just highlight that, click copy, click here, and then paste values only, right, to ensure that you're only putting the values there. Next thing we need to do is to figure out what our percentage of sand is, right? That's the first question mark. Wherever we see question marks on this sheet is where we're going to have to actually either put or paste values or paste equations or enter equations. Okay, so the first thing we need to do is look at or figure out what our percentage of sand is. And that should be fairly straightforward, because the sand, silt, and clay should make up 100% of your soil classification. Right? We've got organic carbon in there as a percentage, but generally if you were to go buy a bag of soil or something from, let's say, Bunnings, then you'd see something like 40-40-20 written on the bag, and that is usually the sand, silt, and clay percentages that you're given on the bag, so that you know what type of soil that is. Loam is typically 40-40-20. Okay, now that means that all we need to do to figure out what our sand is say it's equal to 100 minus the silt and minus the clay, right? You can see that ends up being 93 for soil number 1. So we've got 93% sand, 2% silt, and 5% clay for soil number 1. Now, this is our saturated water content, And you should know by now that saturated water content is the same as porosity. And there is a relationship between bulk density, particle density, and porosity. And it is something along the lines of porosity, this thing over here, is equal to 1 minus the bulk density divided by particle density, which we don't actually have a value for at the moment. But if you've done any experiments where you've had to use particle density before, you should know that it's generally the same for almost all soil types and rock types as well. And the value tends to be around about 2.65 or 2.64. So in this instance, we'll just use 2.65. Hit enter, and that should give us our saturated water content. Now let's move on to what we need to do here with the pedotransfer function. We're going to be entering the pedotransfer function equation in this column over here, but you should be able to tell straight away that you can't enter it in this one over here, in this cell, because you don't actually have values for A, B, C, D, and E. Without the values for A, B, C, D, and E, the equation would be completely pointless, and it's this equation here that you're going to be entering, by the way. So this is at a matrix potential of 0, and if you've learned anything so far in soils, you need to know that when the matrix potential is 0, you have saturated conditions, which means the water content must be the same as the saturated water content, which is this value over here. So to figure out what that question mark is, all you need to do is hit equals, and then target that specific cell over there, and that's it. That's that question mark sorted out. For the next one, we have a matrix potential of -20. We need to use the pedotransfer function here to get our water content over there, right? So that means this cell must be equal to A, right, which is that value there, plus B multiplied by our sand, plus C multiplied by the clay content, plus D multiplied by the organic carbon, plus E, which is a bit tricky to target because we've got this equation in the way, but we know it's 31 and G, so you can just put G31 in there, multiplied by, and it's going to be the bulk density, which is that value there. Okay, now if we hit enter, that should give us our value for predicted water content at that matrix potential. And what you notice straight away is that there's actually quite a big jump between the two, and that is correct. I'll talk more about that a little bit later on when we get to step 3 over here. As you can see in step 3, we don't have as big a jump. We start from roughly 0, and it takes quite a while before we get to -20, which is what you're seeing over here. So there's quite a bit of information that we're missing when we're using the pedotransfer function, and that's the whole point of doing this exercise actually, but I'll talk more about that in the later steps. Now if we were to copy this formula down to the rest of the cells, what would happen is our target cells would move as well, and that's fine for the A, B, C's, D's, and E's because we want these values to be part of the next function. But what we don't want is these values to shift over here. So everywhere where we've targeted values here, which you'll see by clicking in the function bar, if you click in the function bar, it highlights all the cells that you're targeting. So all of these cells here, we do not want to move when we copy the function down this column, right? So that means this value here, this value here, this value here, and this one here, we don't want to move at all. Right? So to fix it, all we need to do is put $signs in front of both the letter and the number. And there is a shortcut to doing that, and that is to highlight the whole thing and hit F4. But my computer's not doing it while I'm recording for some reason. Probably a problem with Adobe Captivate. But we'll just put it in manually and we should be fine. Right? So once you have the values fixed, with dollar signs in front of each of them. Just double check that it's pretty much the second term after every multiplication sign. Right, so missed one here. Right, so that one's fixed, that one's fixed, that one's fixed, and that one's fixed. Right, once that's done, put the cursor to the end and hit enter just to be on the safe side. That value hasn't changed. If we now copy this down, it should just populate for us straight away. And to check that you've done it correctly, just click in the last column, click in your expression bar, and ensure that the cells that you're targeting are correct. And if they are, then that's it. You've completed step 1.